Now friends, we will come to the properties of timber. Timber, as you all know, should have some specific properties for which it is used, and these are divided into two major categories: physical properties and chemical properties. First, we will deal with physical properties. First physical property which is important is tensile strength. Tensile strength in context of timber refers to maximum amount of pulling force a piece of wood can withstand along with the grain before it breaks, essentially measuring its resistance to bring pull apart. It's one of the key strength properties used to assess the structural integrity of timber in construction application. It depends upon first, grain direction. The timber is strongest when pulled along with the grain, meaning that the fibers are aligned with the pulling force. Species variation. Different wood species have different variety of tensile strengths, with hardwood generally exhibiting higher tensile strength as compared to softwoods. Moisture content. Higher moisture content can significantly reduce the timber's tensile strength. The second property is shearing strength. Timber shearing strength referred to the resistance of a piece of wood to the forces of attempting to slide its fiber apart, essentially measuring how to shear the stress a piece of wood can withstand before falling, and it is considered a critical property when designing timber structures, particularly in areas where wood pieces are joined together. It depends upon the species of wood, moisture content, grain orientation, and presence of defects all influence of the shear strength. Crushing or compression strength. Timber crushing and compression strength refers to the maximum load a piece of wood can withstand before falling apart. Force is applied directly on the grain, essentially measuring how much pressure it can take before being crushed. It is a key indicator of wood of structural integrity when used in construction application where compression forces are present, like posts or beams. It is governed by following factors. Timber is strongest when compressed parallel to the grain, meaning the force is applied along the wood fibers, and it is significantly weaker when compressed perpendicular to the grain. Different wood species have varying compression strength, and factors like moisture content play an important role, which is drier wood is higher, generally being stronger. Compression strength is measured by applying compressive load to a wood sample until it falls, allowing engineers to determine its maximum resistance to crushing. The fourth important property of a timber is bending strength. Timber bending strength is ability of a timber to resist its bending without breaking. It's also known as flexural strength. Timber bending strength is an important measure of the load bearing capacity and stiffness of a wood component. Factors that affect timber bearing strength are direction of the load. Timber is stronger when load is applied parallel to the grain rather than perpendicular to it. Size. The size of the stressed volume affects the timber bearing strength. Span depth ratio. The ratio of the span of length of the specimen depth affects the timber's bending strength. Anvil ring orientation. Whether the anvil rings are parallel or perpendicular to the load direction affects the timber's bending strength. Next ability is stiffness. The stiffness coefficient of a timber is a measure of timber's ability to return to its original shape after being subjected to a force. It's used to calculate the stiffness of timber panels and walls. A higher stiffness coefficient means the timber is less likely to deflect under load. It can relate it to the density. The width of the annual growth rings in timber can indicate its strength. The sixth important property is toughness. Timber toughness is the ability of wood to withstand sudden shock and blows. It is also known as impact strength. It is an important factor for timber components that absorbs shock like tool handles, ship hulls. Toughness helps timber to resist breaking and splitting. The next important factor is the density and porosity. The density and porosity of wood depends on its cell size, cell shape, thickness of cell wall, presence or absence of air spaces or intercellular spaces. The density of wood ranges from 0.04 to 1.4. Wood up to 0.5 is lighter wood, 0.5 to 0.7 is medium, and 0.7 and above is called hardwood. The next point is flexibility. Timber flexibility is the ability of wood to bend and curve without breaking. It's a natural property of wood that can be enhanced through various techniques. Timber flexibility allows the creation of shapes and structures that would be difficult or impossible in conventional wood. Timber can be easily adjusted or expanded to meet the changing needs. Timber is lightweight and strong, so it is safer to work with than heavier materials. Products can be shaped and machined on site, which can save time and money. Next point, which is important, is cleavability. Timber cleavability is the ease with which wood can split. It is a mechanical property of wood that measures how well it resists splitting when forces are applied across the grain. The knots can weaken the timber and make it more likely to crack and rap. The position, size and number of knots can affect how much they weaken the timber. Woods with long knotty fibers are more likely to split. The 10th important point is hardness. Timber hardness is a measure how resistant the timber is to indentation, dents, dings and wear. Juncker hardness test is the industry standard for measuring timber hardness. Timber hardness is important for determining timber suitable for flooring. 11th point is durability. Durability of the timber refers to how long a piece of timber can last in a given environment. It depends upon timber's natural durability and how it is treated and used. For example, treatment, whether the wood has been treated with preservatives or minimum hazard grade. Location, whether the wood is used to be on ground or above ground. Manufacturing, how the wood has been milled and manufactured. Maintenance, how the wood is maintained. And species, the natural durability of the wood species. Moisture content. Moisture content within the timber refers to the percentage of water present in the wood, calculated as weight of water divided by the weight of the wood. Expressed as percentage, essentially how much water is contained within the wood compared to its dry mass. The moisture content is always expressed as a percentage. Freshly cut tree can have moisture content ranging from 40% to 200%. The ideal moisture content for timber depends upon its intended use. The indoor applications usually requiring lower moisture levels than outdoor applications. Chemical properties of timber. Chemical substances that are found in wood and whose quantity and quality defines the difference between wood and timber. Substances that components of cell wall, intercellular spaces and or are present in the lumen of hollow dead cells. Higher percentage of cellulose and hemicellulose is responsible for hardness of the timber. Lignin and tannin are responsible for its durability. It has cellulose 45 to 70%, hemicellulose 15 to 30%, lignin 20 to 35%, tannin and phenolic substances and oils